Hello, PHS Algebra 1 students. Today's lesson is coming to you live from Mrs. Stanton's basement. I hope you guys have had a relaxing couple of weeks, and unfortunately this is continuing a little longer than we had all originally planned. So with that being said, we need to get on to this new material. So today we're going to talk a little bit about quadratics. Well, what the heck is a quadratic? In the past, we have been graphing linear equations, which take the shape of a straight line. It can go like that. We could have a line that goes this way. We can even have lines that go straight side to side, or even up and down. Okay? These were all linear equations that all took the form of y equals mx plus b. Okay? So today what we're going to do is we're going to get into a little bit more interesting type of equation. And this type of equation is called a quadratic. Okay? So I have what look like your notes here in front of me. So let's talk a little bit about a quadratic. What the heck is this? Okay, a quadratic essentially is a polynomial function of the second degree. What does that mean? So it's a polynomial of the second degree. And really, guys, what that means is that it has an x squared term. Okay, it may still have a single variable term. It may still have a constant term. But the important thing to note here is that its greatest value is the x squared. It cannot have an x to the third. So standard form, again, I mentioned earlier that the standard form of a linear equation is y equals mx plus b. Well, the standard form of a quadratic is something that you've actually seen before. We just got done doing a whole bunch of factoring and solving by factoring, and this form is just that. We're going to say f of x, or our y, equals ax squared plus bx plus c, where our a, our b, and our c are each numbers. Okay. With that, we went into factoring, and that took the form of parentheses, x plus a number times x plus another number. Okay? So a couple things to know about quadratics. They are not linear. They are what we call parabolas. And a parabola, that's a fancy way, help if I could spell for you guys this morning. A parabola is what takes the shape of a U. It can go up like that. It could go down like this. What's important to note that it is not a V. Okay, it's not a V. You guys will get into that in another year of math. Another thing to note here is that quadratics have symmetry. Okay, what you see on one side is perfectly replicated to the other side. So another point here is the symmetry. And lastly, they have a maximum or a minimum value. And again, we'll talk about that in a little bit. X-intercepts. Let's talk about those for a second. I want you guys to take a look at this graph here. An x-intercept. A couple things about this. This is where the graph crosses the x-axis. Okay? It's where it crosses the x-axis. Now, on our graph here, that's going to be at the point 4, 0 and at the point 2, 0. Those are our x-intercepts. Another word for x-intercepts that you may hear roots. You may hear someone call them the solutions. Or you may hear someone call them the zeros. Okay. Um, so with that, a couple things I want you guys to know here. We can have one, two, or no solutions. Um, if we're looking at a graph, if it's got one solution, that means it's going to run down and it's going to simply touch the x-axis. If it's got two solutions, it's going to cross over it in two spots. And if it has no solutions, that may be something like this, where it never quite gets to the x-axis. Okay. The next thing I want to talk about is the y-intercept. Just like in graphing our lines, the y-intercept is where it crosses the y-axis when x is 0. Okay, so if we look over at our graph here, down here at this point, this is our y-intercept, where it crosses the y-axis. Okay. Now, the axis of symmetry. We actually, this is where the quadratic will reflect itself. Okay, so what you see on one side of this axis of symmetry, you will see the exact same thing on the other side. This is a imaginary line. Now, the one thing, again, guys, I said imaginary. It's not actually a part of the graph, but we use it to help ourselves. This axis of symmetry, what we'll do is we will label it as a line of x equals. Now, what this is it's the point negative b divided by 2 times a. Okay, so negative b over 2 times a. And with that b and that a that I'm getting that from, that goes back up to our original a, b, and c up top in the standard form. Now the vertex. The vertex here, that is the highest or the lowest point of the polynomial, kind of that tip that it comes to. But again, remember, it's a u, not a v, so I really don't like calling it the tip, but it's the highest or lowest point. Okay, when it's the highest point, we call this the maximum. Okay, when it's a lowest, this is what we call a minimum. Minimum. Okay. How we get the vertex. Okay, we are going to plug our axis of symmetry back into the original equation. And solve for y. Oh, I'm sorry, you guys can't see that down there. Plug the axis of symmetry into the original equation. And with that, we're going to get a point. The axis of symmetry will be the x value, and then that value that you found by simplifying the equation gets us as the y. On this graph here, this point down here, this is our vertex. Okay? Now, I just threw a lot of information at you. I'm not expecting you guys to get all this. So let's go through and look at some information. What we're about to do actually reflects back to the graph that we just used examples on. Okay? So with this, I want to talk about this equation that I give you. I give you guys an equation that's in standard form. In this example, it's going to be x squared plus 2x minus 8. This actually does go to the graph that's up above it, but we're going to look at things a little different here. How we actually got that graph. And the first thing to note what is this equation in factored form? Well, you guys know how to factor. We need to pull out a greatest common factor first. In this case, there isn't one, it's just 1. And we're going to go ahead and factor this. Multiply the outside, drop down the inside. What multiplies to make -8 but adds to +2? In this case, that would be +4 and -2. So we're going to take this over to our factored form. Okay? And just like we did when we factored, we're going to say y equals x plus 4 and x minus 2. That's it. You now have the equation in factored form. The x-intercepts. Remember last unit where we solved these and we've said x equals this and x equals that? Well, that's this case. We're going to look up here at this factored form, and if I solved each of those equations, I would get that x equals -4 or +2. How I write these intercepts, it's going to say -4, 0 and +2, 0. This is what x is when y is 0. Now, to find the y-intercept, we're going to use our original equation, and I'm going to plug in 0. The x-intercept is when, the y-intercept is when x equals 0. So we're going to use this equation over here, and we're going to plug 0 into those x's. So we're going to say that y equals 0 squared plus 2 times 0 minus 8. And when I simplify that, I get that the y-intercept, where x is 0, is -8. Okay? Now, the leading coefficient. Guys, this one's easy. My leading coefficient is my a term. So in this case, a equals 1. That's always going to be your term in front of the x squared term. Now, where we get into a little bit more math here, the axis of symmetry, I told you guys to take -b over 2 times a. So b in this case is 2. So I'm going to say -2 over 2 times a, which is 1. So when I simplify that down, let me change color here so we can see it a little better. When I simplify this down, that's going to say -2 over 2, which equals -1. My axis of symmetry is going to be at x equals -1. Which way does the parabola open? We didn't really talk about this. Again, when we're deciding which way it's going to open, a couple things to remember. If it's positive, if my a term, if my leading coefficient is positive, it opens up. If my leading coefficient is negative, it opens down. So this problem, my leading coefficient was a +1, which means it opens up. My vertex, this we're going to go back and use this axis of symmetry here. We're going to take that -1 that we got, and we're going to plug it into the x's in this equation, and we're going to say that y equals, in parentheses, -1 squared plus 2 times -1 minus 8. When we simplify that down, that gives me 1 minus 2 minus 8, which equals -9. So my vertex is going to sit at the point -1, comma, -9. The vertex represents a maximum or minimum. Okay, so we need to look at where the vertex is. If the vertex is at the bottom, that means it's a minimum value. And if it's at the top, that means it's a maximum value. So here, in this case, my vertex would be at the bottom, meaning it opens up. It's at the very bottom. So this is going to be a minimum. My vertex is the lowest, the smallest amount. Okay? I know, again, that was a lot, guys, so let's go on to the second page of these notes.